Hello, now audible? Hello everyone, now audible? Yes. Good morning. How are you all? कैसे हैं आप लोग? Hello Naru. How are you all? It's all going? Doubts with still doubt. Okay. Today's topic in the continuation of vector we are going to do is relative velocity, one of the application of vector. So if all set with pen paper in hand, all good, we can start with it. And before that, there is a form in your description box for joining this STAR program. You can fill it up. Do fill it up with accurately, okay, and be part of this. Okay, so we are starting. Ready for relative velocity? 1, 2, 3. Get it. First of all, we will define it. What is relative velocity? Why this term? See, everything is relative. Everything in this world, in this universe is relative only. Like someone is very fast, someone is slow. Someone is very tall, someone is not that. Someone is fat, someone is not that fat. So everything is relative. Whatever you describe adjectively about anyone, you are describing it relative to something else. So there is a reference, and relative to this reference something is more or something is less. That is the entire idea of relative. So relative, how to go? See, when I talk about motion, when we talk about velocity, physics, relative velocity in general is what? It is velocity of an object, with respect to a moving object or another moving object, you can say. So when you are calculating velocity in physics, your velocity, car's velocity, anything which is moving, that velocity you want to calculate, but you are not calculating with respect to earth. What are you calculating? You are calculating velocity with respect to another object, and that another object itself is moving. So velocity of an object with respect to a moving object, that is the entire basic idea of relative velocity. Understood? So second object must be moving. First object, velocity of an object, object 1, that is whose velocity you are trying to measure, that may be at rest also. Maybe at rest or maybe in motion. Right? Maybe in rest or maybe in motion. But the reference from where you are measuring it, that reference can be another body, the reference can be another surface. The reference is some surface, some body, some observer who is measuring the velocity. That reference is always moving. Reference is always moving. So this is the idea we are going to get today. Just telling you what is meaning of relative. Suppose this is me and I am at rest. But I am at rest. When I say I am at rest, I am saying this with respect to ground, with respect to earth. Okay, I am absolutely at rest, standing on the floor and standing on the ground. But there you are going, you are saying me, hi sir, how are you? And you are passing me, and you are moving with velocity v. I am standing on the road and you are on a bike, you are in a car, you are crossing me, passing by me. When you will see me, when you will observe me, I will not be appear static to you, whereas I was static with respect to ground. But when you will observe me, you are going right, I will appear moving left to you. You are moving forward, I will appear moving backward to you. So that's why I said that object 1 may be at rest also or may be in motion also. But reference, who is measuring, reference means observer who is measuring, that observer always moving. So if this is 1, this is 2. If here I will say whose velocity? Velocity of 1 with respect to 2, and that 2 is moving. So that is called relative velocity. That is the basic idea of relative. So what is relative velocity? Relative velocity of velocity measured of any object, any observer with respect to, that is important, with respect to who is measuring that observer, that another surface has to be moving. That is the basic thing. Is this all okay? The basic definition you understood. The first object, the second observer, object, observer, their state of motion is clear in mind. What is mandatory? Object must be moving or observer must be moving. That is the single thing you have to get in mind out of this slide discussion. So answer me this. First question to you for this. For relative velocity, object should be moving or observer must be moving. What is the answer? So I am looking at the chat box now. Answer me for this. Why reference is to be in motion? That is the relative. Tanmay, if reference is not in motion, it is called absolute. Like suppose I am taking example of earth, static surface. So absolute motion means your reference is not moving. And relative motion means reference is moving. That's why it is relative. Observer, 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 right? So keep in mind, any for relative motion, both object must not be in, not necessarily to be in motion. First object can be in motion, can be at rest. The second who is measuring it, it has to be in motion. That is called relative. Okay. This kind of questions might come in statement question in NEET. Statement 1, statement 2. Statement 1 is saying for relative velocity, both objects or both observers must be in motion. You will write that is false. Only the observer needs to be in motion. Got this? Okay. Chalo. Nice, nice. Anybody room number 303? Yes, Banu. I am in 303 and I will tell you 304 also, but before relative, before that all relative. Okay. Chalo. Go to next. So now mathematically, analytically, we are going to do relative velocity, how to calculate, how to do numerical, and for this, we will see the first very concept of this. Read the heading, that is vector subtraction. Basically, relative is a kind of application of vector subtraction only. So we have to understand this. So we will understand this in full-fledged. Focus here, see what is vector subtraction. When I talk about negative sign that is indicating opposite direction in vectors. Opposite direction in vectors. That is the use of negative when you are dealing with vector. That is nothing but it has nothing to do with magnitude. Magnitude is always modulus, always positive. Negative in vector is opposite direction. So suppose I am saying here I am having a vector A. Right, that is the vector A, and now I am saying I want minus A, so just I need to do is the opposite direction, that becomes minus A. So whenever in any of the numerical you will see negative sign with a vector, you have to keep in mind the magnitude has not been changed, only thing that is changing there is direction, and it has completely becomes opposite. North minus is south, south minus is north, east minus is west, west minus is east. Just 180 degree reversal of direction, that is the meaning of minus sign. So when I say A minus B, and that is vector subtraction, A minus B, what I am doing? I am subtracting B from A. But in vector, there is no numerical subtractions. Magnitude subtraction doesn't work in vector. So you have to understand in vector A minus B meaning is what? A minus B means A plus minus B. We all know we can write it like this. A minus B is A plus minus B. A plus minus B means what we are doing. This sign means what? This sign means vector addition. This sign means vector addition. So what you are doing here, you are doing vector addition. Vector addition is between what two vectors? First vector is A vector, second vector is minus B vector. So what is A minus B? A minus B is A plus minus B. It means it is vector addition of A with minus B. Vector addition of A with minus B, and minus B means opposite direction of B. Opposite direction of B. That is the concept of vector subtraction. So what we do in vector subtraction? If I will ask you what we are doing in vector subtraction, you will answer me, sir, in vector subtraction we are doing vector addition. Vector subtraction mein what we are not doing, subtraction we are not doing. What we are doing in subtraction also we are doing vector addition, but that vector addition we are doing with opposite direction. That is the definition, one line of vector subtraction. What is vector subtraction? It is vector addition with opposite direction. What is vector subtraction? It is same rule, parallelogram law, polygon law, same law of vector addition, but has to be done with opposite direction. For example, if I say this is vector A, right, and that is vector B. Yesterday we did this and angle between them is theta, and I am asking here, beta, I want A minus B magnitude. What is this? Not A plus B, I want A minus B. So you will say, okay sir, you are asking me A minus B. You have told us subtraction is addition with opposite direction. Minus sign in this expression that I am asking you, minus sign is just before B, not before A. A coefficient is plus, B coefficient is minus. So this will be A plus minus B. A plus minus B. It means whose direction we need to oppose? We will oppose direction of that vector with which minus sign is given. So minus sign is here with B. So I will write A like this. I am not changing A because A is plus. But minus B, whatever direction was given, just opposite. So that will be the 2 minus B. So A and minus B, opposite direction of minus B, and between A and with opposite direction of minus B, what we will do? Vector addition law we will use. So this angle in question was given as theta, and this angle will be obviously 180 degree minus theta. So what is the resultant? What is A minus B? A minus B will be A square plus B square plus 2AB. Don't take this minus sign into numerical. This minus is only showing you opposite direction. Don't do that mistake. Minus B means it is less than 0. That is not less than 0. Magnitude of vector, numerical value is never less than 0. 5 and minus 5 both are more than 0, right? Minus 5 in vector means direction is opposite to plus 5. So don't take minus sign the way you take in numbers. Here minus is only indicating only a denotion which says us direction is opposite. I cap minus I cap, J cap minus J cap. There is no less than 0 concept in vectors, right? So I will not write minus B. So here I will not write minus B. When I am writing number, I will write positive number. Direction I have opposed, minus means opposite direction, that I have done already. After opposite direction, again I will not count minus. Minus is one word, direction opposite, that we have done. Now it is B. In magnitude calculation we will use B. But when I will write cos, that will be 180 minus theta, because angle between A and B is not theta anymore. A and minus B angle is 180 minus theta, and that will be A square plus B square minus 2AB cos theta. For problem solving, we will keep that in mind. What is vector subtraction? What is vector addition? A square B square 2AB cos theta. What is vector subtraction? A square B square minus 2AB cos theta, right? Like one example I am taking here. One example A. This is a velocity v1 and that is the velocity v2. What is, I am not asking relative as of now, I am simply asking you, what is v1 minus v2? What is this? This magnitude, tell me. So you will say, okay sir, v1 minus v2, these are in opposite direction. So angle between them, opposite line angle, is 180. So just you told us the formula, it will be v1 square, right, v2 square minus 2 v1 v2 and cos 180 degree. That is the given angle between them. Also we know that cos 180 is minus 1. So if I will put cos 180 minus 1, minus minus plus, that would be v1 square plus v2 square plus 2 v1 v2 under root. And that will be v1 plus v2. Okay, So if I am asking, see, what is the irony? I am asking you vector subtraction and we end up getting vector addition. That's why number addition subtraction should not be in your mind. Vector has its own laws, own rules. That rules, those formula we need to follow simply. With numbers like 5, 3, 7, number arithmetical addition subtraction will always try to confuse you in vector. Simply get it that those rules are not valid here. They have their own formula. Subtraction formula is this. Addition formula here come plus. That theta you have to put the original angle between the given vectors. Okay. So I have done with the second slide, vector subtraction. Basics of vector subtraction, summarize quickly, wrap up quickly. Vector subtraction is vector addition with opposite direction. Whose vector direction is opposite? Any vector whose coefficient is minus, minus a, minus b, minus c. That direction we need to reverse. What we will do after reversing? After reversing, reversion is done, minus sign rule is over. After reversing, we have to use vector addition, that is parallelogram law, polygon law, whatever rules we have done in vector addition, that we will apply after reversal. Okay. Now, any doubt in this slide? It's your call now. Whatever you want to ask me, ask. How 180? It is 0. Better direction is opposite. Venkata Shiva Kumari, see this direction arrow, please focus now. This arrow is V1 and this arrow is opposite. Opposite direction, this opposite, that will be 180. Same direction 0, opposite direction 180. Focus on direction, Babu. I am from Sri Chaitanya Goshala. Okay. Understood everyone? Can we go to next? Vector subtraction is vector addition with opposite direction. Explain the process again. Okay. I am summarizing the process. See again everyone. What we have done in this. Now stop scrolling, put your pen down and see just for 1 minute you will understand. Negative sign means opposite direction. So my question asked me A minus B. We don't have any direct formula or concept for vector subtraction. Keep in mind, vector subtraction is just vector addition only. There is no new formula. Everything is same as vector addition. Only one change you need to do and that change is opposite direction. So A minus B. A sign is plus but B coefficient is minus. So that is A plus minus B means addition of A with minus B. Addition of A with minus B. Minus B means opposite direction of B. In my question B was given as right. So opposite direction means minus V will be towards left. This angle was theta. So it's supplementary angle here. That is 180 minus theta. I have reversed B. I have told you so many times. After reversing, after doing minus, just think vector addition. Now think vector addition. This is A. This is B. Angle between them is 180 minus theta. What is the vector addition law? Parallelogram law says that A square plus B square plus 2AB cos 180 minus theta. This is the angle. Cos 180 minus theta. Cos 180 minus theta is minus cos theta. So that is A square B square minus 2B. In numerical you only have to use this. What is vector subtraction? A square B square minus 2AB cos theta. What is vector addition? A square B square 2AB cos theta, both under root. Okay. So I hope you got this. With more practice and discussion will you get it. Y cos, yesterday we did Charan. Parallelogram law addition is this. You can see the 8th day video. Y cos is coming, you will get to know. Yes, example I am taking short. This formula I told you. Taking the example after this, see. After vector subtraction, all relative we will do this only. But before that, expression for relative velocity. That is the thing we are going to do. Expression, how to write relative velocity. See. This is me, your own Abhishek sir. Abhishek sir is moving with velocity v1. And this is, you can choose your name. Whose name I have to write here? Tell me, I will write. You are moving with velocity v2. Relative expression we will see. Whose name I should write? Chalo, any one name I am writing. Bhanu, your name I am writing, right? In next question, other name we will. So Bhanu is moving with V2, Abhishek sir is moving with V1. Now, I am asking, understand this concept very well, right? Don't do anything else. It's a very basic one line here and there, and every concept will be shattered. So please listen very carefully. I am asking velocity of 1 with respect to 2. That is the concept. Whose velocity we want? We want velocity of 1. But why we want velocity of 1? Velocity of 1 to already given. It was V1. So why we need velocity of whatever is given? Why you need that? Because this V1 is with respect to Earth. That is called absolute velocity. With respect to ground, your car is moving, bikes are moving, bicycle, we are walking, all on ground we are walking. That is called absolute velocity. So with respect to ground, so what velocity is given to us? That is given absolute velocity. Absolute. Now what we want, we don't want velocity of 1, we want that velocity of 1 which is measured by 2. Velocity of 1 with respect to 2, that is all we want here. Now, what is the physics behind it? What is the maths behind it? That we have to understand. Okay. See, what is the velocity of 1 with respect to 2? The point is how it will measure. How 2 will measure 1. Here comes Newton's inertial frame or Newton's relative velocity concept. That concept is velocity of 1 that is calculated. Please focus on this. Please see this. What is the basic concept? Velocity of 1 that is being calculated by assuming 2 be at rest. By assuming 2 to be at rest is called relative velocity. Is called relative velocity of 1 with respect to 2. Obviously this is going complicated. What is this 1 then? But whatever I am writing now, that is the practical calculation that we do. So I will come to this, but take a very simple example. And you all please answer what I am asking. Forget this, I will come to this. First, practically we want to talk what is relative. I am running on a road with 10 meter per second and you are ahead of me. You are ahead of me and you are running with 15 meter per second. When we say normal velocity, that is with respect to Earth always. I am not mentioning 10 meter per second is my velocity with respect to whom. I am not mentioning, it means by default it is with respect to Earth. So I am running with 10, you are running with 15. When I will see you, what velocity I will measure? You are running with 15 and I am running with 10. That is the velocity is given. So when I will see you, you will appear to run with 5 meter per second. How I calculated this 5? Because I put myself at rest. I did not consider myself running. I was running with respect to Earth, but with respect to me, so I am static. My hand, my mouth, my entire body of no position is changing with respect to myself. I am static or I am running. My hand is here only. So with respect to me, so I am at rest only. No. So this person who was moving 10 meter per second with respect to ground, with respect to himself, he was at rest. So his velocity will be minus. Why I am subtracting this? So that I can put it at rest. 10 minus 10. Minus 10 means it is static. Now the same minus 10 I will do here. So 15 minus 10 will come 5. So means what you have to do, now please understand here what you need to do. What is the point here? समझते हैं इसको. Point is, now read this, everyone. Velocity of 1 that is being calculated by assuming 2 to be at rest. If I am asking with respect to 2, your mind should strike, here I have to make 2 at rest. I'm asking with respect to 1. Your mind should strike, okay, 1 I have to make at rest. So first work, make 2 at rest. Step number 1. Question is asking with respect to 2, put 2 at rest. But the question again comes how? Question 2 is to moving. How to make 2 at rest? 2 is to moving. So when 2 is moving with V2, supply minus V2 to this. Obviously it will be static. V2 minus V2, that will be static. Now your 2 has what velocity? 0. How this is 0? I did a maths. I put minus V2 because I have to put 2 at rest. That is the concept of relative. I am asking your relative with respect to left. Assume left to be at rest. Assume. I am not saying it is actually at rest. You have to assume. How to assume? Whatever velocity is there, the same amount of velocity put in opposite direction. It will come at rest. And the same thing you have to do here also. Same thing you have to do here also, V2. But its actual velocity was V1. So it will be V1 minus V2. Now read this. Velocity of 1, that is being calculated by assuming 2 to be at rest. When I assume 2 to be at rest, one velocity became V1 minus V2, which is called relative velocity. So relative velocity means that velocity which you are calculating mathematically by putting the second body at rest. If you are not putting the second body at rest, if you will assume the second body the way it was, your relative will never be calculated. So the basic maths of relative is this. This is just a calculation purpose. This is not the concept. This is the entire maths you have to understand. What is the maths? One more example we will take. Keep looking at an example. Suppose this is lift. Have you been to lift, everyone? Lift, like elevator you have seen. So this is the lift. Where this lift is going? It is going upward with velocity V2. Lift is going upward with velocity V2. You are standing inside the lift. Since you are standing inside the lift, you are also moving with V2. Unless you are jumping in the lift, you are scrolling. If you are simply standing in the lift, lift is moving with V2, you are also moving with V1. Now, I am standing on the ground waiting the lift to come. I am static, I am not moving. This is the body number 1, this is the body number 2. I am asking you, what is the velocity of 1 with respect to 2? That is a very simple question I asked. Now what you will think, you will focus here. I am asking velocity of 1 with respect to 2. With respect to 2, make 2 at rest. Whatever is written after with respect to, make it at rest. So you have to make 2 at rest. But how to make 2 at rest? What maths I told? Whatever velocity is there, put that in opposite direction. So lift velocity was V2 upward. So on this, put V2 downward so that V2 will cancel and its total velocity will be at rest. Now, if this V2 you are putting in opposite direction, do same thing here also, V2. Now, what is velocity of lift? What is velocity of 1 with respect to 2? Velocity of 1 is V2 downward. Velocity 1 is V2 downward with respect to 2. Actually, he was static, but when he will see, and you think, no, you are going in lift up, you are looking something down, it will appear going down. So when you will see, its velocity will be down. So what is relative velocity? What is VA with respect to B? It is VA minus VB. Why minus VB? Because it means it is that velocity of A, it is that velocity of A when B velocity was put 0. That is the theme you have to understand for entire relative. Velocity of A with respect to B means make B at rest and then measure velocity of A. That velocity is called relative. If you will not make B at rest, if you will not make second body at rest, then you cannot observe relative velocity. Again, I am saying this is the maths. This is how we calculate. It has nothing to do with the basics of physics here. This is the mathematical calculation. Now, your call, ask. I will elaborate the point. After that, we will see some questions. Okay, come with your doubts in relative. Okay. Come. Where are you from? Sir is from Sri Chaitanya Goshala. Anyone lagging with classes? Many one. If you're lagging, you can tell. We can help you with this. Sir, once again, can you explain why not? Nikhil, sure I will. Why can't we take VA equal to 0? Deepika, VA is the actual, I told you in the proper definition also. Have a look. Here I told you, please Deepika, it's for you. See, object 1 may be at rest also. Object 1 may be in motion also. Who is measuring should be static. Who is, like I am measuring your velocity. So how would you be concerned? You are not even aware that I am measuring. Why you will be at static? So if I am measuring, I am observer, I will make myself at rest. The object whose velocity, you are standing on road or on somewhere earth and you are looking at a train. Train is not aware that you are measuring its velocity. So observer who is measuring its velocity, the observer, the measurer, that has to be adjust its velocity in order to measure. So obviously V2, V1, if I will ask you velocity of 1, velocity of 2 with respect to 1. Deepika, you answer. Velocity of 2 with respect to 1. Now whose velocity you will make 0? 1 velocity or 2 velocity? Yes, beta, please maintain the notes. Whose velocity here you will measure? Velocity of 2 with respect to 1. Whose velocity you will subtract? Whose velocity you will make 0? 1. See, I am writing many things for your note purpose. But all of this can be summarized in one line. Please understand that line. Whenever I am measuring relative velocity of A with respect to B, see what is written after with respect to. B is written, make B static. And when B is static, then see velocity of A. Taking one, two more example, right? Why should subtract the object velocity with reference velocity? That is the relative, Venkat, it's the meaning, Shiva Kumari, whatever. It is the meaning of relative. See, that I told you in relative here. Relative definition, try to understand. Why to subtract when you ask? You have to understand what you want to calculate. I want to calculate your velocity with respect to me. But I am also moving. Relative means velocity of an object with respect to a moving object. So when I am also moving, then your velocity will be relative. I am static, you are static, there is nothing relative. So I am moving, you are also moving. So obviously I will not observe your actual motion. Your actual motion is with respect to ground. My motion is also with respect to ground. So I will observe something different. That something different motion that I will observe, its magnitude is calculated only when I am static. Then I can calculate your velocity. Now you tell me, to make myself static, I was earlier moving, to make myself static, what I should do with me? I have velocity, but I want to make myself static in order to measure your velocity. So what I will do with me? I will make my velocity 0. How to make it? I have V, I want 0. So I will subtract V. This is the only thing we have, no? Understood? Okay. Now one very simple example I am taking. Question solving will give us more idea about this. Fill up the form first and we will do. One is already in rest, so velocity of 2 will be minus V2. Exactly, Deepika. Yes. One is at rest, but that doesn't matter to V2 because V2 is not at rest. Second body is not at rest, Deepika. So when you are moving, I am at rest and you are moving up. When you will look at me, you will not look at my actual motion. You will look at the motion that appears to you. You are going up. So if you first make yourself static, how? To put V2 down. And that same V2 down put on me also. So you are rest, V2 down on me, so I will appear moving down to you. That is the point going. Okay, more example we'll see. Arey, talk to me also. You are not talking to me. Hi, hello, I am waiting so much. I will go tomorrow. I will talk to you. You are talking yourself here. There is no reward for my waiting. No. Talk to me also. Say hello, sir. Hi, sir. Sir, this, sir, that. You are talking. I am from here. I am from here. I am from Goshala. No one is talking to me. Arey, 39C. Answer you are saying. I am good. I am good, beta. Thanks for asking. No one is asking also. You are busy in yourself. Okay, problem shirt is with me. You come here, I will give you that problem shirt. Don't worry. See this, this question for you, question number 1. A car moves. Please understand relative from this question. Whatever we have discussed earlier, the same thing will be here. If not got any of the point, focus on the question for 2 minutes. Car moves towards east. So that is the car. I'm making one card for you. You can take it without any cost also. This car is moving, but wheels I will not give you. It is moving towards right 54 km per hour. Convert this into meter per second. Come on. Meter per second, 54. How much? Into 5 upon 18. Your 7th class concept. That is becoming how much? 15 meter per second. So this car is moving with 15 meter per second towards east. That question has given. Okay. And observed by a bike moving towards west. Now this is bike. Don't know how to make bike, so I'm making like this. This bike is moving towards west with 15 meter per second. This is the velocity. Now this is body number 1. This is body number 2. What is the velocity of car as observed by the bike? Who is the observer? Bike is observer. Now tell me everyone, whose velocity you will make 0? Whose velocity you will make 0? Bike or car? Whose velocity you will make 0? Whose velocity you will make 0? Whose velocity? Step by step we will go. Bike or car? Who is observing? Observed by bike. Bike velocity is 0. That you have to understand. Ye seekhna is that simple. Velocity of 1 with respect to 2. 2 is 0. With respect to bike. Bike is 0. That way you have to say. Now second question. How to make bike velocity 0? Bike is to moving with 15. How will you make bike velocity 0? That is your entire system of car and bike. Now you have to measure with respect to bike. Whose velocity you will make 0? You will make bike velocity 0. How can we make it 0? 15 in left, give 15 in right. That I am saying from so long. Just give opposite velocity mathematically. When I am giving opposite velocity, then this 15 and this 15 is making bike velocity 0 because they are in opposite direction. But this 15, focus and arrow, this 15 and that 15, are they in same direction or opposite? So on car, what is happening? Car actual velocity was 15, and when you are supplying this 15 here, 215 car is getting, that is 30 meter per second. This is not actual velocity. This is the velocity of car. This is the velocity of car, which is calculated by making bike 0. And whenever you are calculating velocity by making other object or observer 0, that is called relative. So velocity of car is equal to 15, but velocity of car with respect to bike is 30. That you have to understand. We can solve this in vectorly also. That description wise is solved like this. Now formula wise solving, please have a look. Question is asking velocity of car with respect to bike. Now direct formula I am using, that is velocity of car minus velocity of bike. That I told you in the formula, VA minus VB. Where is velocity of car? Velocity of car is towards right. How much is that? 15. So what you will write? You will write 15 I cap. Towards right hand side, that is x-axis. X-axis unit vector is I cap. Minus. This minus is part of formula. Now write velocity of bike. Velocity of bike was also 15, but since it was towards left, I will write minus I cap. So I will write 15 minus I cap, and all of us are aware minus into minus is plus. So that is 15, 15, 30 I cap plus I cap means towards east. That exactly we got here. You see we got towards east, towards right, 30 meter. That is description, that is formula. Just you have to write VA minus VB and you have to put their individual values, you will get the final answer. But that is not the concept. I want you to get this. Why we are subtracting? I will ask you, someone will ask you, okay, why relative is VA minus VB? Why not V car plus V bike? Why not V car dot V bike? Why not multiply? Why not divide? Why not addition? Why subtraction? Then you will answer, okay, sir, we have to make it 0. And non-zero to 0 we want to make, we will opposite. Now we will subtract it, then it will come 0. That is the point. Hello, my dear friend. Yes, friend. Another question. Many questions are there. I will give. But is this coming to your mind? We have to make velocity 0 of a moving body. Thank you so much. Yes, Samniti Sukesh. One good message you said. So nice of you. So nice of you. Thank you. See, I'm smiling by looking at your message. Okay, but do form, all of you, do fill the form in the description, be part of STAR program, and my shirt is waiting for all of you. Okay. Now see this question, read, solve this question, and one more gift will be waiting for you. Just tell me you have solved it. Again, this is today's ABS, although it is a very, very simple question, but it is today's ABS. I hope you remember ABS, Abhishek sir, special questions. Okay, solve. I cap is unit vector, it shows direction towards x-axis. If you say towards x-axis or east, you can say I cap, just a direction. Atif, thank you so much. God bless. Now solve this question. Solve this question. You can say all the, yes beta, see all the previous videos of STAR program, every chapter in very good manner, series manner, sequential, it has been taught there. You can see all those lectures, videos, and then you can come. Now this question we will discuss. Okay, velocity of police jeep is 90 km per hour. This is quite a high velocity, but chalo, I am saying that this is velocity of police jeep, 90 km per hour. So this is the police jeep. I don't know how jeep looks like. I think like this something. One wheel only I will take in this. Police jeep velocity is 90 km per hour. Focus on the question, focus on the concept, what we are doing. Analysis by you have to do. That is what how learning is evolved. 90 into 5 by 18, my dear students, that is 25 meter per second. Babu, police jeep is moving. And after that there is a thief also, and thief is moving with 72 km per hour. Poor he will be caught. His velocity, thief velocity is 72 km per hour, and convert into meter per second, that is 20 meter per second. That is the thief velocity, and that is the police velocity. Nothing I have done, just converted that into meter per second, right? Now actual question starts. Focus here. At a point, thief crosses 10 seconds before the jeep reached. Now this you have to think by reading the description. What is this? What question says? I am saying at a point, let's say P point is the point. P already we have taken for police. So change this. Let's say this is the P point. T for thief, A point, Abhishek sir point. Okay. This is A point. At this A point, according to question, I will not add anything on myself. Question is saying at a point, thief crosses 10 seconds before, when thief reached, and then thief crossed. Thief crossed, but thief has moved up to 10 seconds, and then police has reached here. So how much time thief has crossed, how much time before thief has crossed it? This is the point. First thief reached and thief crossed. 10 seconds, then police reach here. So when police jeep is at A, thief has moved for 10 seconds, but thief velocity was 20 and it has moved for 10 seconds. So how much distance it must has moved? Velocity into time, that is 20 into 10, that is 200 meter. That's the question. Question can directly would have told us that thief is 200 meter ahead of police, but that question is not saying. It is asking us to calculate. If at a point when police has reached, thief has crossed that point 10 seconds before, and then in 10 seconds with 20 meter per second of speed, the thief has crossed 200 meter. Now the situation is this: police is here, thief is here, and distance between them is 200 meter. That is the situation. We have reached up to here. Now tell me one thing in this. How easy is that? Listen everyone. Chat box I am opening. Answer me. If you are catching the thief, isn't it easy? Listen everyone. Isn't it easy that thief is stopped and you go and catch him? Whose velocity will be 0 in this question? Whose velocity you will make 0? Thief velocity you will make 0? Thief velocity you will make 0? Or police velocity? Whose velocity you will make 0? Thief or police? Whose velocity you will make 0? Thief or police? Don't make police velocity 0. Otherwise, how would you catch him? So police will move, right? Thief velocity 0. So but thief actual velocity was 20. How you will make thief 0? Thief had a velocity of 20. How to make it 0? Opposite. So entire question, this entire concept, opposite we will give 20 meter per second of velocity. Thief was moving with 20 minus 20. So thief velocity will be 0. 20. This you have to do. This opposite you have to apply. That question will not apply. You want to make thief 0. Whatever thief had, apply in opposite direction. That is something you need to do for taking this. Don't make police 0. Other how you will catch? I mean, you want to catch the thief by making police velocity 0. Out of the world here. Slow clap. Slow clap for you. You want to catch the thief by making police 0. Wow. Yeah. So this thief, Mr. Thief is 0. If Mr. Thief is 0, if second body is 0, first body velocity becomes relative. VA minus VB. So first velocity was how much? 25. Second is how much? 20. So police velocity will be 20 minus 20, that is 5. So these two are the same situation. Moving with 20, moving with 25, moving with 20, moving with 25, or static and moving with 5 are the same situation. This is absolute motion, that is relative motion. You have make a moving body static, that is relative. What is the distance between them? 200. How easy is this now? Thief is static, police is going, catching him. How much distance police will go? 200. With what velocity? 5. Why 5? It was 25. Why 5? Because when police had 25, thief has 20. When thief has 0, police has 5. That 5 into time, how much time it will take? 40 seconds. The poor thief will be caught. I am feeling bad for him, but it is how it goes. Because he was running with the lesser velocity, he will be caught for sure. Okay? Got this? 40 seconds you got? Police can run 100 in 4 seconds. Venkat, I know that is little unrealistic, but okay, it is like this. Now tell me the second part. Yes. Tasneem, you are absolutely right, and that what we are going to discuss in the next part of the question. Please read. Road distance covered by the police. I think you are also discussing that. Road distance covered by the police. I'm not saying the distance will be only 200 meters. That I never said. When thief is appear to static, then with respect to thief, police will cover 200 meters. Not actually. Now second part of question is asking road distance covered by police. Now tell how much is road distance. When see here, last question, last discussion. When I discuss road distance with respect to road, so you will have to take velocity of police with respect to road and multiply by time. What is velocity of police with respect to road? Velocity of police with respect to road was 25, time was 40, that is 1000 meter. Actually, police has not moved 200 meter, it has moved 1000 meter, but thief has moved 800 meter. So with respect to thief, it has moved how much? It has moved 200 meter with respect to thief. Okay, so tomorrow we will meet with next topic. Bye for this. Practice it. See the video again. Try to understand the basics. That is important. Question practice can take place further. Okay. Chalo. Bye bye all of you.
Good morning, everyone. Good morning, bacha party. How are you? Fine. I am audible and visible to you. Is it audible and visible to you? Good morning. Good morning. Good morning, everyone. Good morning. Right. So yesterday we were doing our topic molarity. Right. Good morning. So in molarity, what we did? What is molarity? Number of moles of solute divided by volume of solution, right? So from that, now we are moving to next type of question in molarity, right? The topic was, we discussed yesterday also, the topic was molarity change on dilution. I told you yesterday, dilution means addition of extra water. I have a solution. In that solution, I will add some extra amount of water. Because of addition of water, volume will change, right? And that's why the molarity will also change. That's why the molarity will also change, right? And if I am just adding extra water, so you will see the number of moles or number of particles here and number of particles here will remain what? Same. And as I said yesterday, the number of moles are what here? M1 V1 and number of moles what here? M2 V2. Number of moles on both sides are same. So I can say M1 V1 equals to M2 V2. So if someone asks you a question, find the molarity after dilution. So please just apply this one. What is it? M1 V1 before dilution equals to M2 V2. What is it? After dilution, right? So we will do some question on this, right? So please. We have written this already yesterday, right? So I am giving you some small question here. So please give me answer. Look at this now. I am giving a small question on this basis. Please answer. Very, very easy. Look at this carefully. I have a solution here. Imagine it is a glucose solution. So I am saying it is 0.4 molar solution. And its volume, which I am saying its volume is 300 ml. It is 0.4 molar solution with volume how much? 300 ml. And now I am adding extra water here. I am adding extra water. I am doing dilution. I am adding extra water. So you will see the volume of solution will increase. The volume of solution will increase, right? So you will see here I am having. Now I am having total volume, I am saying. Now I am saying find the new molarity of solution here. And the volume become how much? I am saying volume become 1200 ml. Before dilution, 0.4 molar, volume 300 ml. After dilution, you have to find the new molarity if volume become 1200 ml, right? So please apply M1 V1 equals to M2 V2. Please do it fast. Yes, everyone. Give answer fast. Very good, very good. Right. Cheerful astronaut. Very good. Right. Very good. Yes, bacha. You see, what is the formula in case of dilution? M1 V1 equals to what, bacha? M2 V2. M1 V1 equals to M2 V2, right? What is M1 here? M1 is 0.4. What is volume here? 300 ml. What is M2, bacha? M2 we have to find this time, and V2 how much? 1200 ml, right? So from here, if you go to find M2, what is coming? 0.4, 300 will cut down this. What is coming? 1 by 4. So what is coming from here? 0.1 molar. 0.1. Yes, everyone is doing right. Almost everyone doing right. Little mistakes. 0.1 molar. Molarity before dilution, molarity after dilution, right? Clear, bacha? Very good. Right. Well, bacha. Okay. Next I am moving. Next question, bache. Same basis, same question. Please give answer carefully. Don't make mistake. Here we have a solution. Imagine I am saying its molarity is 0.5 molar. Okay, and here I am saying its volume, imagine its volume is 300 ml, right? I am adding water here, I am doing dilution, I am adding extra water, and because of addition of water, which you will see the volume will increase. Now here I am saying the molarity becomes 0.1 molar. The molarity becomes 0.1 molar, right? So first your task is you have to find the volume here after dilution, and next thing is find the volume of water added. Next part is find the volume of water added. Please do it fast. Yes, everyone. Very good, very good. Yes, apply just M1 V1 equals to M2 V2 in case of dilution questions. Fine. Yes, 1500 ml, right? And second part answer also fast. Very nice, good. Very good. So you will see, bache, what do we have? I will apply again M1 V1 plus M2 V2. Here we have 0.5 into 300. M2 is 0.1 and we have to find V2. So V2 from here very easy. If you are checking, it is coming how much? 1500 ml, right? But sometime they ask question, find the volume of water added, right? Now so I mentioned two clear questions, A and B. But sometimes they will ask directly how much volume of water will be added, right? So don't make mistake. If I am finding volume of water added, so don't forget to do better what? V2 minus V1. Final V2 is how much? 1500. Initial was how much? 300. Don't forget if they ask volume of water, right? So it is 1200 ml. Please be careful, right, bacha? Right? Very good. Now please, one more question on this, then we will move forward. Right? Same question I am giving. Find volume of water we should add, right? Is to find volume of water we should add in 0.3 molar 200 ml solution to make it 0.1 molar solution. Is it fast? Yes, everyone? Yes, please. This time I am not making diagram. You have to think by yourself. You know the initial M1, you know the V1, M2 is given, M1 is given, V1 is given, M2 is given. You have to find the volume of water added. Don't forget. Very good. Most of you are giving answer 600. Right. But be careful. Don't forget I am asking the volume of water added. Right. So don't forget V2 minus V1. Right. Very good. So we can see, we will apply bacha here the same formula. M1 V1. What is M1 V1? 0.3 is M1. V1 is how much? 200. What is M2 bacha? 0.1. Can you find V2 from here? Yes. V2 is going to be how much? 600 ml. But as I said in the question, I am asking find the volume of water. Find the volume of water, right? So don't forget about it. Volume of water, if they are asking bacha, what is that? V2 minus V1. How much coming? 600 minus 200. How much coming? 400 ml. Very good. I hope you are clear now. I hope you are clear. If they ask the final volume of solution, it is 600 ml, right? But if they ask the volume of water added, V2 minus V1, how much extra water we added? 400. Clear? Okay, right. Now everyone is giving right answer. Fine. Very good. Okay, bacha. Next type of questions we will see in molarity now. Okay, bacha. So please, I am moving next to next part. Next thing is molarity change on mixing of solutions. Molarity change on mixing of solution, right, bacha? So please carefully give the answer. First understand this point. I have here these two solutions, right? I have here two solutions here. Understand very carefully. Assume in this I have Na moles, and in this solution I have Nb moles, Na moles, Nb, right? Now bacha, I am mixing both solutions together. Imagine it was Va, volume was Va, volume is Vb. Here volume become what? Va plus Vb, right? Total volume become Va plus Vb. My question is, if in this we have Na moles, if here I have Nb moles, so in this solution how many moles will come? In this final beaker, when we will add both, so total how many moles are there? Is the answer fast? Very good. Very good. Right. So in this you will see the total moles become how much? Na plus Nb. If I will mix both of these, moles become what? Na plus Nb. Right? Very good. Clear, bacha? Now, understand this very carefully. How we find the moles? How we find the moles? Using molarity. We know that. What is molarity, bacha? We know. The molarity is what? Molarity is M equals to N by V. So what is moles? Moles are N are what? M into V. So in first solution, how many moles we have? MaVa. In second solution, how many moles we have? MbVb. Right? So in the final solution, when you added both, so how many moles we have? It have moles beta MaVa plus what? MaVb. Getting my point? Total moles. Clear, bacha? And if I call, understand this very carefully. Now, if I call its molarity as M3, if I call its molarity as M3 and volume V3, so it is what? M3V3. If for the final solution, I am calling molarity as M3 and volume V3, so what is it? M3V3. So in case of mixing, bache, how to find the nu? Remember, in case of mixing, what you will do? You will do M1V1 plus M2V2 equals to what? M3V3. Getting my point? Or you can say here, it's what, bacha? M1V1 plus M2V2 is M3, and what is beta V3? Normally when we mix two solutions only, V1 plus V2. So if you mix two solutions and they ask find the molarity of final solution, then just apply this formula. I am saying once again, if you mix two solutions and they are asking to find the molarity of final solution, apply this formula very easily, you can get your answer, right? So from here, bacha, what is coming? If I say what is coming? M3 here. M3 is coming what? It's M1 V1 plus M2 V2 divided by what? V1 plus V2. Okay, yes everyone, clear? Now on this basis I am giving questions, so please answer very carefully, right? I'm saying once again, it is the type where I am mixing two solutions to make a third solution, right bacha? Clear? Very good. So next I am saying, answer this question bacha. Look at this. I have a solution here. Assume it is 0.2 molar solution and volume I am saying imagine 300 ml. Plus I am mixing one more solution here. Its molarity is 0.1 molar and volume is 400 ml. And both solutions are made up of same thing, means glucose. In the final solution, if I added both, so please find the molarity here. Find the molarity. If I just mixed both the solutions, so in the final solution, find the new molarity. Is everyone fast? Yes. Fast. If I am mixing two solutions, then find the molarity of final solution. Very good. Very good. Right. Very good. So you can see, bacha, I am applying which formula? M1V1 plus M2V2 equals to what? M3V3. Fine. What is M1 here? You can see it is 0.2 into 300 plus 0.1 into 400 equals to what? M3 to V3 is what? 700. If we combine both the volume, right? So what is coming from here? If we add, what is coming? Tell me. 60? 60 plus how much? 40 equals to M3 into 700. So yes, bacha, what is coming M3 value? M3 value coming 100 by 700. How much? 1 by 7 molar. It's coming 1 by 7 molar. Very right. Very good. Great. Very good. Right? One more question of same type. Okay, bacha. So please see. Same question I am giving. I am mixing two solutions. Here we have 0.3 molar urea solution, 0.3 molar urea solution having volume bache 300 ml plus I am mixing 0.4 molar urea solution having volume 400 ml, right? So please, on mixing, find the final molarity. Question is, find molarity of final solution after mixing. If you are mixing both, then find the molarity of final solution. Is it fast? Is everyone? Fast. You're doing great. Very good. Very right. Very good. Deepika asked a very good question. I will answer. First we will do this, then I will ask, right? See. Right? Deepika Bachcha, I will answer your question by after this question, right? Look at this. What is M1? M1 is 0.3. What is V1? 300 ml plus what is M2? 0.4. What is V2 Bachcha? V2 is 400 ml, right? M3 I have to find, and definitely what is V3 here? I am just mixing. Here and volume become how much? 700 ml, right? So from here, if you find bacha M3 is coming how much? Please. What is coming from here? 90. What is coming from here? 160 divided by how much? 700. 160 plus 90, which are how much coming? 250 divided by how much? 700, right? Clear, bache? So what is coming finally? If we cancel out this, right? Right, everyone. What is coming? 5 by 14. It's 5 by 14, right? Clear, bacha? If I say once again, it is what? M1 V1. Is bacha? 3 here, 0.3 into 300, how much will come? 90. M2 V2. M2 V2 gives me how much? 160. 160 plus 90, how much? 250, right? And total volume, how much now? You can see total volume was 400 plus 300, how much? 700. So 250 divided by 700, 5 by 14. Right, everyone? I hope you are doing great. Yes, right. Now Deepika asked one question and it's very important, right? So you will answer the question first. Okay, bacha? Look at this now. Understand this. I said very clearly in the molarity formula, we should take volume in liter or in ml. Tell me. When I said, please find the molarity. What is that? Number of mole by volume. Volume should be in liter or ml. Tell me. Volume should be in liter or ml. Yes, everyone? Volume should be in liter or ml. In the molarity formula, bache, it should be liter, right? It should be liter. If you see your slide or your notes, you will see it should be liter. Very good. But now, when I was applying the formula M1 V1 equals to M2 V2, or when I applied the formula M1 V1 plus M2 V2 equals to what? M3 V3. In those questions, I was taking volume in what? ml. So how we can take this, right? Understand this carefully. If both side I am taking volume in ml, and if you want to convert it into liter, what I will do? If I take volume in ml, then I will divide by what? 1000. I will divide by what? 1000. So if both the sides volume is in ml, so it will cut down. Yes? If both the sides, if you take volume in ml, it will cut down, right? So units will be what? Same. You cannot do in one side I am taking liter, in one side I am taking ml. So whenever these questions are coming, so please, if you take ml or liter, but both should be same. So it will not make any issue. It will not make any issue if you will take both sides same units. Both can be ml or both side can be what? Liter also, right? Similarly here, bacha, if you take here, you convert ml into liter or liter. So you will see these things are cut down. That's why it will not change anything, right? But both sides unit must be same. Both can be ml or both can be liter, right? Yes, everyone? Are you clear now? Yes, Deepika? Are you clear? Yes, Deepika, bacha, are you clear now? Very good. Fine. Good. So in such question there is no issue if ml comes. But if question comes only on molarity, then be careful, you have to take liter. Clear, bacha? Right. Okay. Now we are moving to the next one. Okay, next type. Question on molarity. Fine, bache? Now, next thing is molarity relationship with what? Weight by weight and weight by volume percentage. We have done two terms, weight by weight percentage and weight by volume. Now we will connect both with each other, right? So please, First thing is, if you want to find molarity from weight by volume percentage, I am saying first, what you will do? The formula is 10 into weight by volume percentage given divided by molar mass of solute. It is molar mass of solute, right? It is molar mass of solute. Clear, bacha? If they gave you weight by volume percentage and they want to ask the molarity, please use this direct relationship. We will see how we can derive it, but in the main classes when you will arrive here. For now, just remember this direct formula, right? So do what? 10 into weight by volume percentage divided by molar mass of solute. So please, bacha, answer this question. Question is, find molarity of 10% weight by volume NaOH solution. Find molarity of 10% weight by volume NaOH solution if, I am saying with a hint I am giving here. What is our hint? The molar mass of NaOH. Maybe you are not aware of this thing. It is 40 gram per mole. Molar mass I am giving. Molar mass I am giving, right, bacha? So please answer it very fast. Just apply the relationship. Just use relationship and give me answer. Fast. Yes, everyone. Just apply the relationship upside given and find molarity from what? Weight by volume percentage. Very good. 2.5, 5 by 2, 2.5, 2.5, 2.5, 2.5. Yes. Great. All are saying 2.5, right? We'll check. Look, bacha. What we had to do? We are finding molarity. How? 10. 10 into the weight by volume percentage. How much given here? Weight by volume. 10. Divided by molar mass of solute. Molar mass of solute, how much? 40. So from here if you check, bacha, 100 by 40. How much coming? If you divide this, what is coming? Yes, very good. 2.5 molar. It is 2.5 molar. Very good. So most of you are doing great. Right answer. Right. Very good. Yes. We will see, bacha, when you will come to the main classes in next month, we will see all these derivation also. Right? We will see the derivations part. Clear? Now, next thing. Same question I am giving one more. Please. Find molarity of 9.8% weight by volume H2SO4 solution. Clear, bache? And hint I am giving again. The molar mass of sulfuric acid is 98 gram per mole. Molar mass you can find by yourself also if you know the atomic weight of different elements. But still, for now I am helping you by giving. Please, yes everyone, fast. Molar mass I am giving. How much? 98. Molar mass is given to you. For sulfuric acid, 98. Very good. Very right. Right. Very good. See, bacha, what we can do? Solution. I am finding molarity 10 into weight by volume percentage. How much? 9.8. Divide by molar mass of what? Solute. What is that? Our solute is sulfuric acid, right? What is that? 98. How much coming? 98 divided by 98. How much coming, bacha? 1. It's coming 1. Very good. Right. Very right. 1. Fine. Okay. Now, the next short trick is, now we will see the next part. how to find molarity from weight by weight percentage. How to find molarity from weight by weight percentage, बच्चे, right? How to find 10 into weight by weight percentage. What is it here? Divided by molar mass of solute. One new thing will come, that is into density of solution. Into beta density will also come. In weight by volume there was no density, but in weight by weight we have to use which one? Density. That is a new thing in this formula, right? It is the relationship of weight by weight percentage with what? With molarity. Weight by weight percentage relation with what? Molarity. Fine, bacha? Right? I am giving one question here. Okay? Right. Very good. Yes, everyone? Clear? Just extra thing is what? Density. So please write the question. Find molarity. Find beta molarity of, if I say here, imagine 6% weight by weight urea solution, right? Or if I change a little bit, take it 12, right? Find the molarity of 12% weight by weight urea solution. Now beta, what is given? If density of solution imagine I am saying it is 1.2 gram per ml. 1.2 gram per ml, right? And hint I am giving which hint I am giving the molar mass of urea. The molar mass of urea is 60 gram per mole. So please just apply the formula, give me the answer fast. Just apply the formula, give me the answer very fast. Yes, bache, fast. Apply the formula, give me answer. 4.8, 2.4, 2.4, 2.4. Most of you are giving 2.4 answer. We will check. Fast. Yes, everyone. Yes. Fine. Very good. I am finding molarity. What is coming? You see, bache, 10 weight by weight percentage, 12 divided by the molar mass of solute, how much? 60 into density, how much? 1.2, right? Density is 1.2. Very good. You see from here what is coming? 12 will cut down this 5. 5 cut down this, how much coming? 2. 2 into 1.2. Very right answer. It is 2.4 molar. It is 2.4 molar. Right. Very good. I hope everyone is clear now. Okay, bache? Very good. So it is a type of molarities. So we have finished our main types of molarity. Now we will see some questions overall. Mixed question, right? 1 or 2 questions we will see. Okay, bacha? Now, find this question. Solve this question, bache. Question is, how many moles of Na2CO3 are there in 10 liter of 2 molar solution? Yes, everyone. They are asking simplest question of molarity. Please answer. Just for your hint, if you remember, molarity is what? Number of mole by volume in liters. Please give me answer. Molarity is number of moles divided by volume in liter, right? 20, right? Yes, very good. So it is very much clear. We can see the molarity is how much? Molarity is how much? 2 molar. I want to find moles of solute. Volume is how much? 10 liter. Number of moles coming how much? 20. I can say 20 moles of solute. And what is that? Na2CO3. Clear? if by chance if they ask you weight, if by chance they ask you weight, so very easy. Can you find weight of vitamin Na2CO3? Yes. How we can find? Number of mole into what? Molar mass. Okay. If I say number of moles, how many? 20. The molar mass, maybe you are not aware up to now, but it is how much? 106. Okay. The molar mass I am giving you, don't worry about it. When you remember atomic weight of all the elements, you can find by yourself. Yes, 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 very good. Okay, you are giving answer, fine. What is coming? 2120 gram, very good. Molar mass, if I just give you a hint little bit, how you can find molar mass, bacha? Imagine it's Na2CO3, right? Molar mass of sodium is how much? 23. Sodium. How many sodium? 2 sodium. Right? Carbon. But carbon molar mass how much? 12. Oxygen molar mass how much? 16. And how many oxygen? 3 oxygen. Right? If you add it, what is coming? So from the atomic weight of every element, or from the molar weight of every element, you can find the what? Molar mass of molecule. Right? Clear, bacha? Okay. Fine, fine. One more question I will say. Please. Find the answer. I am giving a hint here. The hint is, I am mentioning, bacha, the molar mass of CaOH twice, the molar mass I am giving here, it is what? 40 plus 2 into 17, 74. The molar mass I have given, remaining part you will do. Molar mass I have given, right? How to find with a molarity? Number of mole by volume, right? What they have given? They have given that we are having 0.207 gram of our solute in how much volume? 40 ml, right? So what we can do? We can find the moles first. How many moles are there? 0.2074. Mass divided by the molar mass how much? 74. Moles of solute divided by volume of a solution. How much volume, bacha? 40 ml volume. But don't forget to make it what? Don't forget to make it liter. It is ml, na? 1000. Right? So what is coming from here if you check, bache? If you see, it is coming how much? 0.2074. If you solve this thing, what is coming? 25. Divided by how much? 74. Right? Clear? If I take almost it as what? I am taking 0.20 only. So almost you will see it will give me how much? 5. 5 by 74 is coming, right? Almost. If I take this part little negligible, right? Clear, bacha? So 5 by 74 is the answer. Almost if you go, right? This is the answer. Yes, very good. Almost. Okay, bacha. I hope you got all the points. Okay. So please read these topics from NCERT also, and we will share you these notes, right, in your Telegram. And don't forget to fill the form given in description, right? And hope you will join us soon and will get the benefits, right? Okay, bache. So don't forget to fill the form and recommend to your friends as well. Okay, bache. Bye. Thank you. Bye, bache.
Good morning, one and all. In our today's botany class, we are going to start with the next topic under meristematic tissue. But before that, again, we have to recapitulate the point. We already discussed about the meristematic, their introduction. Fine. There we have started discussion about the types of meristematic tissue. Based on the location, last time we had discussed, one is the apical, then is the intercalary, then after the lateral meristem we have discussed, right? So, very good morning all of you. We are going to take some questions now based on our previous. Just say me the study of the tissues. What you call it as? Study of tissues. Quick response please. Meanwhile, other students are even joining. Let's revise. Histology. Very nice, Dikshita. Once again. Histology. Very nice. Once again, Dikshita was the first who gave the response here. Many other are after that. Very nice. Giving the correct response. Keep on participating. So here histology, the word histo stands for tissue, ology stands for to study. The study of the tissues, that you call it as histology. Right now we are discussing about internal morphology of the plant. We are on the histology part. We have to wind up with the histology in our rest of the lectures under the tissues, right? Now one more question for you. Through this slide I am taking that. So here you are having A, B, C, the labelings over there, right? First my question is based on A. A is indicating which type of meristematic tissue. Obviously it is based on the position, right? A is indicating which type? Apical. Very nice. Right? Okay, very nice. Apical meristematic tissue. Now can you say me whether it is of root or shoot? This apical is of root or for shoot? Not intercalary, please. This is not intercalary. I am only asking for A right now. Right? It is apical for shoot. Very nice. This is for the shoot apical meristem. Now say me for the B. For the B now, what it is indicating? B is indicating which type of meristematic tissue? Based on the position. Intercalary. Very nice. Intercalary is the response. Correct answer. This is intercalary. Now what C stands for? What C stands for means telling you about which type of meristematic tissue here. C. Lateral meristematic. Very nice. Very nice. So here the three we have discussed. Actually this is the answer for all A, B and C. A is for apical meristem and B is for intercalary meristem, C is for the lateral meristem, right? So this is one type of the question we say. Now under the apical meristems, yesterday even we have looked to this diagram, part of that diagram we have discussed. Now A is indicating and B is indicating, right? Your options: apical, lateral or intercalary. A and B both are indicating, A and B both now in this diagram, indicating apical, intercalary or lateral meristem. Very nice. Jayashri, you have given the first response correct here, apical 1. Now next thing under A. A it is indicating which type? Whether it is a shoot or a root apical meristem. A is indicating which apical meristem? Shoot apical. So here it will be the shoot apical meristem. Obviously here B is indicating for the root apical meristem. Shoot apical meristem. And here it is having the root apical meristem. Right? So this is about a little bit revision of the things what we have discussed yesterday, right? Now a little bit more we have to go with the meristematic tissue. Characters we have already discussed. They are dividing cell, thin wall, and even they don't have the vacuoles over there. Nucleus is conspicuous, clear, or you can say prominent type of the nucleus is present. Now we have discussed through a flow chart. Let me to take this point, that if I am taking, just for a revision, I am taking the meristematic tissue. Meristematic tissue based on location or the position. We already discussed that is of three types. Just now we have discussed. Again in the revision we have said apical, then we discussed intercalary, then we said about the lateral. Are you getting that? That we have already discussed. Now today class we are going to take, that is based on the origin, right? And if you remember in our last class I already given you this flow chart. There we discussed that is pro-meristem, right? Even it will be the primary meristem, and even it will be the secondary meristem, right? And along with that, the based on what thing we have to go, we even have to go based on their function, right? So based on the function, again what we are having, based on the function, again we are having primary meristem, even we are having secondary meristem, right? So we have already discussed based on the position. Today we are going to take based on the origin, from where it originates, that we have to pick. To understand the various types, we are taking the based on the origin first of all. On that grounds we have to make a one flow chart to understand this concept. I am taking right now about the meristematic tissue, the based on the origin, right? Now based on the origin, the three categories we are looking forward. Now to give a more detail to that, I am giving you one more flow chart for this. Now based on origin, which is the first one, just now we have said, that is the pro-meristem, right? Now what is pro-meristem? Pro means what thing which is already there in the beginning, means in the embryonal cell, when they keep on dividing to give the new parts in a seedling, right? When it is going to form a small seedling, a seed is forming the seedling. At that time what happened? The embryonal cell itself keep on dividing. That embryonal stage you call it as pro-meristem. Are you getting that? That you call it as what thing? Pro-meristem. Clear? Now pro means the first hair which is forming first. Now that part, pro-meristem, the embryo, while it is giving seedling, and that seedling is giving to a small plantlet. So the meristem which is present from the beginning there, that you call it as primary meristem, right? The meristem which is present from the beginning and it originates from the pro-meristem, that you call it as primary meristem, right? Which is present in early stage, or even you can say it can present from the beginning when the small plantlet is coming out, that you call it as primary meristem. We will discuss with one or two examples here. Now I am taking primary meristem, like if you remember we discussed yesterday, the shoot apical meristem keep on growing, but it leaving behind some permanent cell which is giving rise to the leaves. Are getting that? So right now somewhat we will discuss here about a little bit permanent cell, so that we can be clear with the origin of the meristem, right? So primary meristem which is from the beginning in a plant parts that you call it as primary meristem. Now that primary meristem further give rise to the primary permanent tissue, right? Can I say indirectly this is a function of primary meristem which is giving rise to the primary permanent cells. But right now our topic is on the meristematic one. Now let's see now what happened in case of dicots. Now in case of dicot I must write. Before that, all the story what we have discussed up to here, that is happening both in case of monocots as well as in case of the dicots, right? In dicots now, earlier I discussed with you lateral meristem is there, which is increasing the diameter girth of the root as well as of stem. Are you getting that? So lateral meristem is responsible for the lateral growth of the plant in dicots, not in the monocot. Exceptions we will take later, but right now a generalized point of view we are discussing. So do remember both monocots and dicots will show up to at least primary permanent, means a plant is growing. Simply if you don't know the terms, at least you have seen the plant how it is coming out. When you are sowing the seed, it is coming out as a small seedling out, right? So it is giving out the small leaflets. I must say here the leaf primordia, not even leaflets. I must say the word here leaf primordia. Primordia means which appear first as compared to this mature. That leaf primordia will get mature further into the leaf, right? So when you are sowing the seed, the plant is coming up in the form of the shoot, and the down part you call it as root system. In the root you will find the mature region with the root here. Here you will find the leaves, buds and all the things, right? So that are the permanent things. If I am taking about, for example, leaf here, so that permanent primary part is developed from primary meristem, right? And this process you call it as differentiation. Differentiation. What is differentiation? The dividing cell has become now different. They are going to become specialized, but still not all, because meristematic region is still there. This is epicenter that keep on dividing and keep on growing and leaving behind some permanent cell. And that permanent cell, one example in the shoot I have given you for the leaves, right? Or in the leaves you are having mesophyll cell, which is further a permanent type of cell. This is a primary permanent, right? Our main motive is to check it out from where the different meristems are originating. Primary meristem is originating from promeristem. And what is promeristem? Embryonal stage of the plant in an you can say seed when it is dividing. That is embryonal stage, you call it as a promeristem. And the meristem which is present from the beginning in the plant, like apical meristem, help to keep growing the plant. It is from the beginning, right? When you are sowing a seed of a mango plant, listen to this one example very carefully. When you are sowing a seed of mango plant, what will happen? It will sprout out, it comes out in a form of a small seedling. Now once it is forming a small plantlet, it is keep on growing linearly. It will not immediately start showing this lateral growth. Are you getting that? It will show lateral growth later in the life. Are you getting that? So for that lateral growth, what meristem we required? That you call it as lateral meristem, which help later in the life to show the increase in the girth or the diameter or the circumference of the plant. Which plants? Dicot plants. Their stem as well as their root part. Are you getting that? So this is very important thing you must remember here. Promeristem is an embryonal stage which is giving rise to primary meristem. Primary meristem during its growth leaving behind some of the permanent cells. That permanent cell which is forming from the beginning, you call it as primary permanent. Now in dicot, just now I am saying again and again, it has to increase its girth now later in the life. Now in dicots, what thing will happen? Some of that primary permanent cell. Which primary permanent cell I must say here? Which are living permanent cells. The living permanent cells. Because some are the dead permanent cells as well. this living permanent cells, the primary permanent cell, that will de-differentiate. Now what will happen? De-differentiation will happen to convert the primary permanent cell into the secondary meristematic cells. Because the body is now filled more with the permanent cell, we need now, the plant body need now some cells which can again show division for this lateral growth of the plant, and that you call it as a secondary meristem. So can I say what is the origin of this secondary meristem? The secondary meristem is originating from primary permanent cell. Otherwise, origin of all the cells is the promeristem, or you can say primary meristem. It is giving birth to all the cells. But immediate source of the secondary meristem is a primary permanent, by which process? De-differentiation. D here in this word, D means without. Without speciality now. Without speciality means again it will start dividing. Again it will start dividing. Means again it will become meristem. When permanent cells again becoming meristematic, that cells you call it as a secondary meristem. Now why they have become meristematic? When you see the woody trees, na, can you see outside the bark is there? Are you getting that? Not full bark, I must say here, but at least some dead cells are there outside. So this is one of the example which is formed from this secondary meristem. How it is making that, and what is that cork part, what is that bark part, that we will discuss later on this. But right now just remember for a time being that the primary permanent is giving rise to the secondary meristem by de-differentiation. D means without specialization. Without specialization means dividing cells. So they are giving rise to the secondary meristem. So what secondary meristem is doing? Secondary meristem is giving rise to the further secondary permanent cells. Are you getting that? Now what is the process you call it as? Can you see here again specificity is coming back, again differentiation is coming back. That's why you process you call it as redifferentiation. What do you call it as? Redifferentiation. Keep the word differentiation in your mind, means something stop dividing and again becoming specialized as a permanency. Differentiation keep in your mind, I repeat, as permanency. When differentiation happen, permanency is coming. De-differentiation means without permanency, means it will become meristematic. Re-permanency, again differentiation is coming. That means it is secondary permanent. Are you getting that? I hope so. This point is clear to everyone, right? So this is important. If you are understanding this part, 2-3 topics are there in your full +1 and +2 where this concept is going to touch. But basically for today, don't take much tension, only focus on the green box what I had made, even this one, the promeristem part, because we are discussing the origin now, which is present from the beginning, that you call it as primary meristem, which develops later, in the growth, right? That you call it as growth or the life cycle. Better word I must write here. Later in the life of the plants. That you call it as what? Secondary meristem, right? So our main topic we have to focus right now on promeristem, primary meristem and the secondary meristem. If I am taking primary meristem, that means I am talking about right now, means they are developing from promeristem, means I am talking about its origin part, right? So this is very important flow chart in front of you. If you can understand it at least and learn it, I think so you can save your many of the topics which is about to come in your +1 as well as in +2, right? Okay, so let's revise once again this thing, because these are new terms for you. Just focus on the first word we are taking based on origin. Now on based on origin, the meristem is what? Dividing cell. Embryo is that stage in the life cycle of these plants which are keep on dividing. Their all cells are dividing. They are meristematic, that you call it as promeristem. And once it is sprouting to give the body of the plant in the initial state, at that time what meristems are there from the beginning, that you call it as primary meristem. And once it is coming out, primary meristem is going to give rise to the permanent plant parts like the leaves. Like for example, if I am drawing here the stem part, if I am drawing here the stem part, right at the tip, what is there? There is the shoot apical meristem. Shoot apical meristem. When the shoot apical meristem is going to grow, it is leaving behind some leaves now. What are leaves? These are the permanent cell. So can I say this apical meristem, which is primary meristem, has given rise to the leaf part. Are you getting that? That is the primary permanent cells. We will learn in our tissues topic that permanent are of further types. It can be dead, it can be the living one. Are you getting that? Now here, that living one only in dicots help in this secondary growth, means increasing in its diameter. And how it is happening? It is happening by first of all dedifferentiation, then is by redifferentiation. Today's this flow chart up to this part, right, up to this part, it is belonging both to monocots and dicot, because both need the linear growth of the plant as well as the depth of the roots. But to show the width of a plant, if you have revised the previous lecture, only then you can get this concept, because tissues topic or anatomy topic, all the things are linked to each other. Don't miss any of the lecture in between, right? So do remember, once the width is increasing, that is the requirement in the dicot, not in the monocots. That's why the primary permanent again lose its permanency, again it become meristematic, and that meristematic again give this permanent cells back again and increase the girth of the plant. Are you getting that? So this is based on the origin. We have discussed the type of the meristem. Now based on the function, even based on the function, it is in front of you. Now can I say which are giving rise to the primary parts of the plant which help in the linear growth? That is primary in function. Which is helping in the secondary growth of that, right? They are the secondary meristem. Now based on the function, let me to take here, based on function, based on function, I said you two types are there. One is the primary meristem, next is the secondary meristem, right? Now primary meristem helps in the linear growth. Linear growth means lengthwise, whether it is the height of a stem or the depth of the root. That is the linear growth. And which are helping in that you call it as a primary in function. Those who are helping in the secondary growth means what thing? The lateral growth, which are helping in the lateral growth, right? Or helps, or you can say to increase the girth of the plant, or you can say width of the plants, or even you can say circumference of the plant, right? So secondary growth you will find in dicots, primary growth you will find in both monocots and the dicots. Are you getting that? So just a normal routine, like when you are sowing a seed, think about the plant will grow first of all linearly. Either it is a mango or you are sowing the seed of rice or wheat. Are you getting that? They will grow linearly, upside as well as downside. But if it is dicot, you will find they will start growing in the width as well. So if it is increasing in width in the stem, definitely the root is even going in width as well. So this is the feature of mainly of the dicots, right? So do remember, the meristematic tissue have various criteria for its classification. First, based on position, or you can say location. Second, based on origin. Third, based on their function, right? As per we have discussed some example here. Let's talk about some of the examples on this point. If I am taking based on the origin, pro-meristem, I said you these are all embryonal cells. Primary meristem, what example will come here? Which example will come here? Example here will be coming apical meristem and even intercalary meristem, because they are present from the beginning in the plant to increase the length, like apical in the shoot as well as root. Intercalary in monocots, I said you it is present as the base of the internode from the beginning and helping in the linear growth of that. So primary meristems, 1 and 2 examples I have written here. Permanent cells I am not picking right now because you don't know the types of permanent at this point, but they are differentiating to give the primary body of the plant. Like the tip, if it is growing, the primary bodies are what? Leaves are the basic requirement of the plant. It keep on growing and leaving behind some of the differentiated cells which perform some specific function, and that process you call it as differentiation. Now some of the permanent, not all, which are living permanent, that will undergo dedifferentiation to give this secondary meristem. Now what is an example of this secondary meristem? That example will be like cambiums, or you can say other word, what you learned about that lateral meristem. Here the lateral meristem are here, right? And lateral meristem, even you are using the word cambium, right? What word you are using here? Cambium for the lateral meristem. But don't say all lateral meristem. You must write here most of the lateral meristem, most. At least do retain this word here, most, not all, because earlier even I said you in bio there is a big importance of saying all these words, right? So this is about the secondary meristem. Then it redifferentiate to give the secondary permanent, means the woody part they are going to give rise, which is its secondary function, right? So next we have discussed based on function. I hope so you get it. So primary in function will be the apical meristem and the intercalary meristem. Here what example will come? Apical meristem and intercalary meristem, right? But for secondary growth, example obviously the lateral meristem will come. But do remember here all lateral meristem, right? Functionally if you are saying all lateral meristem are going to be showing the lateral growth of that, are you getting? But if you are discussing about origin, there is some exception which we need not to discuss right now, but do remember the word most in that case. If origin, then secondary meristem, most of lateral meristem is coming under secondary meristem. But if I am discussing about function, then secondary in function meristem, all lateral meristem are secondary in function, right? Just keep in your mind this fact. When you will come, then that suspense is even going to open. What is that exception over there, and what are the other cambiums, the name, or you can say lateral meristem, what is there. But till now, to make a concept clarity, meristems are there, permanent tissues are there. You must know the basic differences. The map you should learn that under that which categories come. Now we are switching on to the permanent tissue. What categories will come over there, that we have to discuss, right? So till now we have discussed the meristematic tissue. Now next what we have to discuss is regarding the permanent tissue. But before getting into this permanent tissue, let's talk about their types. Now what are permanent tissue? Earlier even we had discussed, they are specialized cell. They are specialized cell, right, which are no more dividing. They are not dividing. Right? And here the word must be journally. Why journally we have kept it here? Because you know that just now we have discussed here that we are having this type of cell, permanent cells, these permanent, which start dividing again, right? So that's why we have discussed here the word generally. Are you getting that? What we have put the word generally here. The permanent cell generally they are not dividing, right? And they are specialized cells based on their structure. Their structure is becoming different and even the function they are going to be specialized. No more dividing. They are not dividing. They are permanent cells now. Are you getting that? Now, what are the types of this permanent cells? What are its types? Right? The first of all, the heading goes with the simple permanent and the complex permanent tissue. Right? Now, what is the simple permanent now? Do remember the word for this. This is homogeneous type of cells. They are clustering together to form a tissue. And here they are heterogeneous. Right? We are discussing about the types of which cells? We are discussing about the permanent cells. Right? Earlier even I said you the permanent tissues are there, and here we have discussed, just a moment. Right, so here even we have discussed earlier that meristematic tissue, the types we have discussed, and now I am taking for the permanent tissue, right? So here we have said the types are how many? Two types are there, simple and the complex one. I think so yesterday class I have given you both together. Now I am taking separately. Meristematic I have drawn separately the flowchart. Now I am discussing about the permanent, their types, right? Simple are homogeneous. Can you see the word homo? Homo means all are same, right? All the cells which are present here, they are going to be same. You will find there is no difference over there. They are having the common origin, structurally same, functionally same. That is homogeneous. In heterogeneous type, you will get the different types of the cells, but they are collectively performing the common function. Like maybe you have heard about the things xylem and the phloem, right? In the last of the tissues we will discuss about this fact as well. Xylem is further made up of different components, vessels, tracheids, fibers, right? Even parenchyma. Different components are making the xylem tissues. What words I spoke? Okay, let me to write here. I spoke the word here, the vessels, tracheids, even I discussed the xylem, fibers, even I discussed the word xylem, parenchyma. These are the components. Don't say the types of xylem. These are the components of the xylem, right? One xylem consists of so many components. All the things are different here. You will find different in their structures, right? But collectively try to support for one function. What phloem is further made up of? Phloem is further, you can say it is made up of sieve tube. It is made up of companion cells, right? Even it is made up of phloem, parenchyma, and even it is made up of phloem fibers. Are you getting that? So can you see one tissue is made up of so many components whose structures are going to be different, but here it is all going to be same. Such variety will not be there in case of simple permanent tissue. But which simple permanent tissues we are going to take? We are going to take it parenchyma, then we are going to take the collenchyma, then we will discuss about the sclerenchyma, right? Today's work for the rest of the lecture is that we have to focus on the simple permanent tissue that we have to take, right? So I think so you are already aware of these terms. In 9th standard, you have at least the names of that. You are aware with the names at least, right? So it is what thing? Simple permanent tissue. This is a now next map in front of you, that what we have to learn in case of the permanent tissues. I repeat, permanent tissues generally they cannot divide. They are specialized in its structure and function to perform some specific function. Now we have categorized under the simple and the complex type based on whether all cells are same or they are of different type, right? Now I am taking here the simple permanent tissue, where first we are going to take about the parenchyma, then we discussed about collenchyma, then sclerenchyma. To understand that thing, have a look here on this diagram. This is there right now on your board. You will find here, and please look on that point where I am putting my marker over there, this stylus pen where I am putting, just have a look on that part, right? So this cell, can you see all are of same type? Even here, that is all going to be of the same type, even there are of same type. Just now, what is there in front of you? This is the parenchyma. This is which cell? Parenchyma. It's transverse section. Transverse section means when the cells you are cutting horizontally. When you are cutting horizontally, this is its transverse section, right? And this is for the collenchyma. Collenchyma, and even this is its transverse section. Now this is the longitudinal section of the parenchyma. Longitudinal section. You do not worry about the labeling, right? Only focus on the points what I am speaking, right? So here right now, this is for what thing? Parenchyma. It's longitudinal section. One thing, when you are cutting like this, you will find circles, but when you are cutting like this, then you will find this longitudinal things, right? So this is the longitudinal view of parenchyma. This is the longitudinal view of the parenchyma. Collenchyma. I must write here for collenchyma. This is LSV, longitudinal section, right? Again here you are having section here. This is for sclerenchyma. Right? This is its transverse section. This is sclerenchyma. This is its longitudinal section. Are you getting that? So here, do remember all these points. This is important. Right? So three types of tissues: parenchyma, this collenchyma, then is a sclerenchyma. Just have a look on its transverse section. Let's have a look on this parenchyma. Can I say their all membranes are thin? They are thin wall, and you will find a space between that, this much space between the cells. This space you call it as which space? You call it as intercellular space. Intercellular space. As you are discussing about tissue, can you see it is a cluster of cell? This is a one tissue, parenchyma. But what is a feature of parenchyma? That will be thin walled, and they are having intercellular spaces over there, right? And here when you will find the walls become thick in collenchyma. Can you see the corner thickenings are there here? The corner thickenings are there. So once these thickenings are there, wall thickenings, corner wall thickenings are there. That means you are talking about what thing? Collenchyma. And once you find the thickenings all over, very much thick is there. This is very thick cell wall, right? All around the cell. That is the feature, one of the feature of the sclerenchyma, right? If you feel discomfort, don't go with the longitudinal section. Go only with the first, this one, second collenchyma, third about the sclerenchyma. But now what are the other features? What are the other features for this? This is now a little bit tricky thing, and retaining all the feature once go maybe can be a problem. So I am using your mnemonic to learn the feature of parenchyma, collenchyma, sclerenchyma, then automatically be clear to you, right? And do remember, out of these three, the permanent tissues, what is that? Do remember here, this one is the living one. This is living. And even this one is living. But only sclerenchyma among three, that will be non-living. Right? Sclerenchyma will be non-living. I said you know, all parenchyma will no more will be living. Means all, not parenchyma, I must say, all the permanent tissue will not be living. Here right now parenchyma is living, here the collenchyma living, and sclerenchyma will be non-living. Permanent tissues or permanent cells, the different types will not all be living. I repeat here, parenchyma living, collenchyma living, and sclerenchyma will be non-living. Now coming to the characters of that, if I am taking for parenchyma tissue, what mnemonic we can use? I said you it is having thin cell wall, but it is made up of cellulose, that you called as thin cellulosic cell wall. It is made up of, getting that, thin cellulosic cell wall. Are you getting? Cellulose is what? This is the composition of its cell wall in the plants, which is a polysaccharide, or I must say it is carbohydrates. Clear? So meanwhile the cell wall of the plants are made up of cellulose, no doubt, but it is thin, it is not much thick. Now keep this thing in your mind, and now mnemonic what I can use for it, I will go like this. Instead of thin, I am writing slim. Slim cellulosic cell wall. Right? Now to understand these other characters of that, where S stands for what thing? S stands for its shape. Right? Which type of shape they are having? It can have spherical in shape, or even it can be oval in shape, it can be round in shape, it can be polygonal in shape, or even it can be elongated in shape. Are you getting that? The word means we are using or. In one tissue, it cannot be all of same type. All not will be of going to be of same type. I mean to say that all types, I repeat this point, all the different types cannot be in one type, that I want to say. All the different shapes cannot be in one place. Right? At one place you will find only one type of the shapes. For example, if I am taking in case of leaves, you are having palisade cells which are elongated. So that will be elongated part. Likewise, we will discuss later in transverse section where different shape. But right now you should know at one place all the different shapes are not present. At one particular place only one particular type of shape will be present over there. So shape. L stands for what thing? It is living cell. It consists of which cell? Living cells. I stands for it is having intercellular space. Right? But that intercellular space will be small, not big one, or even it can be tightly packed. Tightly packed means they don't have intercellular spaces, right? M here stands for, this is a major component of or component within organs. In the plant organs, this is the major component. When you are talking about the transverse sections of the part of the plant, you will find basically they are mainly made up of the parenchyma. Mainly it is made up of parenchyma. Rest all you know that it is having cellulosic cell wall. Right? Just to learn, just as a mnemonic I have given that. It's your way now. You can learn in another way out. But these are the feature of parenchyma. Now what is the function? What is the main functions of this parenchyma? It can be help in the photosynthesis, like the way I said you in the leaves. It can even help in the storage where the food need to be stored in the plants. Even it is helping in secretion of the substances. like gum, resin, latex, these things can be secreted from the parenchymatous part of the plant. This is regarding the function of the parenchyma. Features I already discussed through the diagram. Now separately I am taking their characters, and to help you a little bit mnemonic I have given for parenchyma. Now coming to the collenchyma. The collenchyma, the word indicating in itself is a mnemonic. Right? I am not only going with this part of it, H and Y. Simply I am saying H and Y. This is not having a mnemonic over there. Right? Let me to check for C. It is having thickenings, no doubt. You remember where the thickenings are there? The thickenings are at corners. Are you getting that? So it is having which type of thickenings? It is having corner thickenings. Right, that corner thickenings, which is made up of what thing? It is made up of hemicellulose. It is made up of cellulose. Even I should write it below the main component over there. What is the main component right now? The cellulose. Right, the cellulose is main. Cellulose, hemicellulose. Then you can go with the pectin. This is the composition of this cell wall, which is at the corner. It is going to be thick. Now O stands for it is observed under what thing? It is observed under epidermis of most of dicots. Most of dicots. L again stands for living. And there are corner thickenings, maybe they use the word localized. Localized. Localized means not thoroughly out the cell wall, only at particular corners. The thickenings are there. E stands for either it is homogeneous or even it can be in patches. Homogeneous means if it is there under the epidermis of the dicot. Epidermis means when you cut the stem of the dicot, you will find upside epidermis. Below will be collenchyma. Now that collenchyma will be continuous or somewhere it will be there. It depends upon plant to plant. That means it will be homogeneous. Homogeneous means it is continuous. Right? Or in patches it can be there. M stands for there is no intercellular space. They are tightly packed. No intercellular space is there. And C stands for chloroplast. Means often. They are having, often means usually. Usually they are having the chloroplast. They even can show the photosynthesis. These are the features of the collenchyma. Now what is its main function? This is indicating its function. M stands for it is providing mechanical support. Mechanical support. Right? A stands for its assimilation. Assimilation means photosynthesis. Right? Mechanical support means if this part is there, it won't allow the part of the plant to drop. Or when the high wind speeds are there, they will not fall down. Right? This is a function of collenchyma to give the mechanical support to the young parts of the plant and even the petiole part of the leaf. Petiole, you remember I discussed with you stalk of the leaf. They flutter in the air. Why? Because in the petiole they are having this collenchyma, which is giving this flexibility to the leaf over there. So these are the features we have discussed for the collenchyma. We will discuss again about this thing we discussed about the permanent tissue. First parenchyma, then we discussed collenchyma. We are still pending with the sclerenchyma. As per the time what we are having third slot even for the tissues. There we are going to complete this permanent tissue. There I will discuss about the sclerenchyma. For a meanwhile, just go up to there, and in the next session again we are going to revise for the permanent tissue, and even little bit if time possible we will discuss about the meristematic tissues. Right? So this is all for today. Thank you very much.
Okay, so good morning everyone. Already Neela Vani, good morning sir, good morning. So now in the last class we completed up to the flightless birds and non-flying birds, already completed. So only one class is remaining related with the tetrapoda. Tetra means four, poda means limb. Four limbs are there, so it is the tetrapoda. So I said that last class is the Mammalia, and what is the characteristic feature of class Mammalia? That is the presence of mammary glands. Presence of mammary glands is the characteristic feature of class Mammalia. So Mammalia, if I will say about the Mammalia, good morning to everyone, Grishma, Neelavani, Krishna, Susant, Charita, all good morning. Okay, so now just coming here, class Mammalia is classified into three. The class Mammalia is classified into three. Okay, class Mammalia is classified into three. One, those who are laying the eggs. One, those who are laying the eggs. One, those who are laying the young ones. And the intermediate class, which are the ovoviviparous. Intermediate class, which are the ovoviviparous. Are you getting? So there are three. Name of the first subclass is the Prototheria. Prototheria. What is the name of the class? Prototheria. Second name of the class, that is the Metatheria. Second name of the class, that is the Metatheria. And third name of the class, that is the Eutheria. Prototheria, Metatheria, and the Eutheria. Proto means primitive. Proto means primitive. Primitive mammals, they are the Prototheria. And what is the meaning of theria? What is the meaning of theria? You will get surprised that we originated from reptiles. Mammals originated from reptiles. Mammals originated from reptiles. Birds also originated from reptiles. So there is one class in the reptiles that is known as the Therapsida. Therapsida. As we originated from Therapsida reptiles, that is why in Mammalia, in all class one term is given, that is the theria. So are you getting theria term? Theria term, it is basically related with the reptiles. Therapsida. Therapsida. Sushant, we originated from reptiles. Reptiles. How reptiles? Because there is a process that is known as the evolution. Getting now? That is why the Prototheria, they are known as the egg-laying mammal. Prototheria, they are the egg-laying mammal. Still they are having the reptilian character. Still they are having the reptilian character. So this is the one point that you have to remember, Prototheria. And we have to discuss one example in Prototheria. This is the one example in Prototheria. Proto means primitive. Theria means that is the Therapsida. Getting now? So now there is one oviparous. Oviparous means egg-laying mammal. We are giving birth to the young ones, but still some mammals are giving the egg. And one of them, that is the Ornithorhynchus, duck-billed platypus. See, duck-billed platypus. It is having the long bill-like structure. Getting? Bill-like structure. That is why it is known as the duck-billed platypus. It is known as the duck-billed platypus because it is having the bill-like. So thus this is platypus. It is the connecting link between reptiles and mammals. It is a connecting link between reptiles and mammals because still it is having the reptilian character. That is the egg laying. So this is the one, Prototheria. After it, we are coming on the next subclass that is known as the Metatheria. 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 If you will see in Metatherian animals, there is one pouch. Have you seen kangaroo? on Discovery Channel. Archaeopteryx is different, beta. All subject corner, Archaeopteryx is different. Archaeopteryx is a connecting link between reptiles and birds. Archaeopteryx included in class apes, that is different one, beta. So this is one metatheria. Yes, someone has written. Yes, Jayashree has written. It is the marsupial. Very good. Marsupial originated from Australia. Deepsika, very good. So they are having one marsupial pouch where the development of young ones takes place. Are you getting? Where the development of young ones takes place. So this is the one point that you have to remember. One example you have to remember, Macropus, that is known as the kangaroo. Macropus, that is known as the kangaroo. So this is the one point that you have to remember now. Coming on the next example, that is known as the Eutheria. Eutheria, U means true. U means true. Theria means, I said now, originated from Therapsida, reptile. So they are the true mammals. They are the true mammals. And they are giving birth to young ones. They are giving birth to young ones. This is the one point. They are giving birth to the young ones. Are you getting? Only mammal which can actually fly. Only mammal which can actually fly, that is the pteropus. Flying fox. Pteropus. Flying fox. Okay, so only mammal which can actually fly, that is known as the pteropus. This is the one point, and you will get surprise. God is great. Bats, yes, you are correct. At the time of flying, their eyes are closed. Only the ears are open. We are not able to walk for 10 feet without opening the eyes. They are flying without opening the eyes. Their eyes are closed. Their eyes are closed. Ears are open. So anyone will say which system is present. Which system is present. What this system is known. Yes. The toxic boy. Please correct your right name because you are giving the correct answer. They are using the echoes. This system is known as the sonar system. Sonar system. Okay, you have given the correct answer. They are producing the high frequency sound. They are producing the high frequency sound, and these high frequency sound they are going, is striking with the object, coming back, and with the help of these sounds they are able to identify their objects. So this is the one point, that they are having the sonar system, which is similar as the radar system. So you all are correct. You are writing correct. That is the sonar system or radar system. That is the Calopus. Camellus. It is known as the camel. Any property related with the camel, anyone will say what is the property of camel? What is the second name of camel? Anyone will say what is the, yes, just say me the name. It is related with desert. Between bats and flying fox, that is the scientific name is different, beta, only nothing. What is the, yes, Maddie, what's the sip of the desert? Camellus is known as the sip of the desert. They are capable to survive without water for many days because they are storing the water, and they are having one hump, that is the storage of adipose tissue. That is the storage of adipose tissue. So they are using the metabolic water. Are you getting? That is why it is known as the ship of the desert. So this is the one point that you have to remember. Camellus, it is the ship of the water. Rattus, rat, also mammalia. Okay, I will go slightly fast. Canis, dog, also mammalia. Okay, Felis, cat, also mammalia. So these are the example. Elephas, elephant. What is the name of this structure present in elephant? What is the name of this structure present in elephant? I make the circle. Yes, 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 yes. Sai Surya, Raj Surya. Tusk. Tusk of the elephant. This is the tusk of the elephant. And tusk of the elephant are modified. Anyone will say the tusk are originated from what they are? Tusk are. Anyone will say what is tusk? What is tusk? It is made up of. It is made up of. Anyone will say what is tusk? Yes, 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 yes. Sai Raj Surya. That is the teeth. Yes, very good. The upper incisor teeth. Upper incisor teeth. Upper incisor. Upper incisor. It is coming out. It is coming out in the form of. Are you getting? So this is the one wonderful point. It is known by you. Tusk of the elephant. They are the modified upper incisor. Okay. So this is the one point. Elephas. That is the elephant. Okay. Now equus. That is the horse. Horse is also mammal. It is included in our family. Getting? Delphinus. Common dolphin. Remember, dolphins are mammals. Dolphin are not fish. Dolphin, they are not fish. Yes, Harshita, you are writing. It is a dentine, a hard, dense, bony tissue, and the whole tusk is wrapped in enamel. Yes. Okay. So this is the one. Delphinus, dolphin. Delphinus, dolphin. They are also. Yes, whale also. Okay, Jayashree, very correct. Whale also included in mammals. Very good. So Delphinus, dolphin. It is a mammal. Okay. It is the common dolphin. That is the Delphinus. Now, Balanoptera. Whale, blue whale. Blue whale is also included in the mammalia. It is also included in the mammalia. It is also included in the mammalia. Yes, Panthera tigris, tiger. See, Panthera tigris, tiger. Panthera leo, lion. And Panthera leo, lion. Just see. So these are the few. Just see. Sea lion, jellyfish. Sea lion, jellyfish. It is also included in the mammalia. Sea lion, jellyfish. It is also included in the mammalia. So I have shown so many examples of mammalia. Okay, just what is written there? Don't forget to subscribe, like, share, comment, and please, if you have not filled your form, finish it fast. Okay, finish fast. The admission form, finish fast. I will come on the next one. Okay, so now we completed about the animal kingdom. Now I am going to ask 5 questions only. I am going to ask 5 questions only. Are you ready? Are you ready to give the answer? Are you ready to give the answer of my 5 questions? Okay, fastest finger first. Devilfish. 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 What is the name of the phylum in which the devilfish included? Fast, 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 fast. Yes, very good, very good. Dushyant. You are the fastest finger first. Devilfish means octopus. Okay, devilfish means octopus, and it is included in phylum Mollusca. Okay, so Dushyant got the first prize. Okay, very good. Now ready for the second question. Ready with your keypad, your fingers, with your presence of mind. Okay. Now the next question is, Pheretima. Pheretima is monoecious or dioecious. Pheretima is monoecious or dioecious. Dushyant, read the question, listen the question carefully. Annelida, that is Pheretima is monoecious or dioecious. Yes, Nikhil. You got the first prize. Pheretima is monoecious. Monoecious means both male and female, they are present only in one animal. Very good. This time, okay, the second one got the first one, fastest finger first. Still you are having the 3 chances. Okay, so participate as much as possible. It will check your presence of mind. It will increase your recalling. Now ready for the next question. Yes, I said na, Pheretima means earthworm. It is monoecious, not dioecious. It is the monoecious. Okay, now coming on the next question. Are you ready? Okay, so now just say me the other name of Hydra. Hydra is commonly known as. Yes, Hydra is commonly known as. Hydra is commonly known as. Hydra is commonly known as. Yes, Dipenbita. Okay, it is known as the freshwater polyp. Freshwater polyp. I'm sorry, I'm not able to pronounce your name correctly, but are you getting to whom I said? Okay, so Hydra is known as the freshwater polyp. And thank you to all, because you all are trying to reply. Okay, very good. Now, coming on question number 4. Take a deep breath. Fastest. Okay, so now the question number 4. Say me, what is the aplysia? What is the common name of aplysia? What is the common name of aplysia? Yes, common name of aplysia. Yes, Dushyant, Chakri, Neelavani, how fast you are. Aplysia is known as the sea hare. Very good. Okay, aplysia is known as the sea hare. Not beta, it is not seahorse. Seahorse is the hippocampus. Aplysia is the sea hare. Aplysia is the sea hare. Yes, you were first, that Neelavani, Dushyant and all 3 I said the name. Okay, because it is taking some time internet to come here. Aplysia, that is the sea hare. All are first, but fastest finger first. You know, in NEET exam that you have to write maximum correct answer. Struggle for existence and survival of the fittest. You all are good, but who will reply very fast and reply correct, he will get a seat. Are you getting now? So you all are good. One more. Yes. Okay, ready. Now you have to reply. Ready? One more. So the last question is, what is the common name of tea frog? Tea frog. What is the common name of tea frog? Yes, Bharti, you are correct that it was given by the Darwin. Yes, Dushyant, then Chakri, all are giving, Deepsika, all are giving the correct answer. Tea frog is known as the hyla. Tea frog is known as the hyla. Okay, so I asked 5 questions. Devilfish included in the mollusca. Very good. Pheretima is monoecious. You all given the correct answer. Then I ask, Hydra is the freshwater polyp. Very good. Aplysia is known as the sea hare. Then I said that tea frog is known as the hyla. Tea frog is known as the hyla. Tea frog is known as the hyla. Okay, you are saying one question more. One more. Very good. Very good. Very good. Very good. Ultimately, you have to play with the question in NEET exam. Na? I am really appreciating that you are saying one more question. Okay. So, you want to reply this time fastest finger first. Okay. So, on the demand of students coming on, again I will give you chance. 3 more questions. Okay. Not one. Ready? Okay. Ready? So, first question is, listen carefully. First question is, say me the name of the example of cephalochordata. Name of the example of cephalochordata. Example of cephalochordata. Example of cephalochordata. Example of cephalochordata. Yes, 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 yes. Anjali, you have given the correct answer. The example is the branchiostoma. Branchiostoma. Branchiostoma, that is also known as the amphioxus. Amphioxus, or that is also known as the lancelet. That is the example of cephalochordata. Beta, seahorse is included in the Pisces, na? Branchiostoma, Krishna, you are right. All subject corner, you are also right. Neelavani, you are also right. So, it is the branchiostoma. Amphioxus. Okay. Okay, now. Ready? For second question, second last question. Okay. So, now, going to ask the next question. What is the common name of sawfish? What is the common name of sawfish? Again, Dushyant. Okay, the common name of sawfish is the pristis. Sushant also correct, pristis. Pristis. It is having a apparatus like sauna. So, that is the pristis. Common name, that is the pristis. This is the one. Okay, you all are giving Tanmay. Okay, Aries, all are giving the correct answer. That is the pristis. Okay, so now last question. Are you ready for the last question? Okay, so coming on the last question. Ready? So I am going to ask. I am going to ask the last question. Ready? Sometime a teacher has to make fun in the class also, na. Last question is very difficult. Who is the most famous actor in the South India? Okay, 1 crore question. Yes, it's a question of rupees 1 crore. Who is the most famous actor in the South India? Yes, Prabhas. You are saying Prabhas, Alazun. Okay, Ramcharan. Very good, very good, very good. Okay, so now I'm coming on the question. Say me, what is my question? The question is, what is the name of, what do you want? What is the name of penguin? What is the scientific name of penguin? Yes. Okay, you said Zoology sir is the famous actor. No, no beta. I'm just happy with teaching to you people, na? Okay, say me the answer of this. What is the common name of penguin? Penguin. Yes, penguin, penguin, penguin. In NCERT it is given. In NCERT it is given. Penguin, yes, Jayashree. You have given the fastest finger first. It is known as the aptenoids. Penguin is known as the aptenoids. Okay, so we will play a lot of questions hour. Every Saturday I am conducting one question hour in my class also. So, and in that question hour, when you will join, I think you all enrolled yourself with Sri Chaitanya. So when you will come here, we will discuss, we will do a lot of games and puzzles and all. Question hour is also there. So when we are conducting the question hour, okay, see, my question hour is having two parts. It is an open session. You can ask, either you can ask the question or I will ask the question. Okay, so this is the one. So when you will come at Sri Chaitanya, we will go for this question hour. So nothing to worry. Now I am coming on my basic thing. That is most important. So we have completed that. Animal kingdom. It has taken 9-10 days. So now coming here, introduction to human physiology. Okay, beta. Now Varsita. Now we will discuss question in some other day. Okay, that when college start. Okay, when college start, they will call you. They will send you the message. So nothing to worry. So now I am coming on another interesting thing, that is the human physiology. Human physiology means, don't think, when you are studying the human physiology, don't think you are studying a subject. Don't think you are studying a topic. Don't think you are studying a chapter. When I am teaching the human physiology, when you are studying the human physiology, just try to get the concept. You are trying to get about yourself. It is the study of ourself. What is human physiology? How the food is digested, how we are going for breathe, how our heart is pumping the blood, how our kidney is forming the urine, how our liver is secreting the bile, getting, and how we are thinking. You are the most intelligent person of the world, na? You know, yes, say me the answer of one question. Say me the answer of one question, that what is the scientific name of human beings? Who will say? What is the scientific name of human beings? Because with the help of scientific name, I want to share you one very good thing. What is the scientific name of human beings? Yes, Sai Surya, you have given the correct answer. Homo sapiens. Homo sapiens. Our scientific name is the Homo sapiens. You know the meaning of sapiens? Sapiens means wise. Wise means intelligent. Your name is saying that you are the intelligent person of the world. Your name is saying that you are the intelligent person of the world. So from today, please recognize yourself. You have to utilize your energy, you have to utilize your power, you have to utilize your knowledge to get a seat in medical college. You getting? So intelligent. So your name is saying Homo sapiens. Our name is Homo sapiens sapiens. It means we are the most intelligent person among the intelligent person. Man of the series, you can say. Okay, Homo sapiens sapiens. So this is the one point you have to remember. So now I am going to say introduction to human physiology. And in introduction to human physiology, I am going to start with the breathing and exchange of gases. What is my target in saying the introduction of human physiology? At least you should acquaint the name of the chapters that we have to discuss here and what we are going to discuss in this chapter. I deleted the first chapter, that is the digestion and absorption. I deleted the first chapter. Basically in previous NCERT, the first chapter of human physiology, that is the digestion and absorption. I am starting from breathing and exchange of gases. Why? Because this chapter deleted from NEET. Now this chapter deleted from NEET. That is why I am going to start from breathing and exchange of gases. So in new NCERT, you will get human physiology from the breathing and exchange of gases. Are you getting? So this is the one point that you have to remember. So breathing and exchange of gases, how many parts of the human respiratory system known by you? We are taking the air through the nostrils, nose. Then a common part is coming, that is the common part of digestive system and respiratory system, that is the pharynx. After it, a part is there, that is known as the larynx, and larynx is known as the voice box, sound box. You can say, what is our sound box or voice box? That is the larynx. Then trachea is coming, that is known as the windpipe. Then bronchi, and ultimately the lungs. Now the question arises, what is the structural and functional unit of the lungs? I think known by you all. What is the structural and functional unit of the lungs? Yes, Susan, you have given the fastest answer. The structural and functional unit of the lungs is known as the alveoli. Alveoli is the structural and functional unit of the lungs. So human respiratory system, it is consist of these parts. Okay. So if I will say, please see this diagram carefully, where the lungs are present. So internally the human body is divided into two cavities. This is one muscular structure. This muscular structure is known as the diaphragm. Diaphragm is a muscle. Diaphragm is a muscle. And with the help of this diaphragm, the human body is divided into upper and lower cavity. Upper is the thoracic cavity. Lower one is the abdominal cavity. Upper cavity, that is the thoracic, and lower one, that is the abdominal, with the help of diaphragm. Very good. And diaphragm is a muscle. What are the structures present in the thoracic cavity? A pair of lungs are there. And we are having the heart. So thoracic cavity that is having the lungs and heart. And what is the structural unit of the lungs? That is the alveoli. Alveoli. This picture I have taken from NCERT. This picture I have taken from NCERT just to increase, because just start studying. Whenever you are free now, please try to read this unit, because this unit is very good. Okay, lumbar cavity, no beta, it is not lumbar cavity beta. Lumbar cavity, why you are asking lumbar cavity? Lumbar is the name of vertebra which is present here beta, lower cavity. Okay, it is the thoracic cavity. This is the thoracic cavity. So please start studying this one. This all is saying directly we are going for the alveoli, but before going to the alveoli, there are so many branches. Okay, so this I will say when you will come here, that now this one is saying about the blood supply, how our lungs are getting. So this I have given the elaborated answer. Okay, so this is the one thing that you have to remember. Now, this is one alveoli. Again, I have taken from NCERT. This is one alveoli. This is one alveoli. In contact with the alveoli, capillaries are coming. Here are the capillaries. Alveoli are lined by a layer of cells like this. And this cell is the epithelial cell. They are the epithelial cell. So, they are the alveoli. Alveoli, the structural and functional unit of the lungs, which are related with the exchange of gases. Okay, what is the function of alveoli? That is the exchange of gases. Exchange of gases. So, if I will say this is the blood capillaries, I will draw separately. This is one alveoli, this is one blood capillary. So, O2 is coming from alveoli to the blood, and CO2 is moving from blood to the alveoli. This is the exchange of gases. Yes, very much correct, Sheikh. Okay, Vasa, that you said it takes place by the process of diffusion. It takes place by the process of diffusion. So this is the one point that you have to remember, that alveoli is there. It is the structural and functional unit of the respiratory system, and alveoli are related with the exchange of gases. Exchange of gases takes place by the process of diffusion. Okay, this process is called as the diffusion. Yes, Dikshita said that it is the hemoglobin. What is the function of hemoglobin? Hemoglobin is binding with the oxygen. It is forming one compound that is known as the oxyhemoglobin. Oxyhemoglobin. And after making this compound, it will carry the oxygen up to the tissues. At the level of tissues, oxygen will be separated from hemoglobin. And at the level of tissues, when it is getting separated from hemoglobin, it will bind with the CO2, HbCO2. This HbCO2 will come to the lungs. It will remove the CO2. So this is the way how oxygen is reaching up to the body cells, and how CO2 is coming back up to the lungs. Anyone will say, what is the name of the compound which is formed by hemoglobin and carbon dioxide? What is the name of the compound? I am writing Hb plus O2 oxyhemoglobin. What is the name of this compound? This compound is not carboxy, it is the carb-amino hemoglobin. Name of this compound is the carb-amino hemoglobin. Very good. It is the carb-amino hemoglobin. So when you will come, I will say this is the mechanism how the volume of air comes in and how the volume of air goes out, means the expiration. Okay. So I said that respiratory system is there, and what is the function of respiratory system? Exchange of gases, transportation of gases and all. So today I have given basic knowledge about the respiratory system. In the next class I will say about the circulation, excretion and all, how much, what is possible. But say me, how many of you enrolled already? Give your thumbs up. How many of you enrolled already? How many of you enrolled already? I will say about the double circulation. Please give your thumbs up. How many of you enrolled already? Yes, very good. Remaining, what about the remaining? Please do it fast. Okay, because your enrollment will increase our confidence that yes, we are going in the correct path. Okay, so we will meet again. Thank you very much. Thank you.